This is the continuation of the video for trigonometric substitution topic. All right, and we're now on problem number 4, and the problem is the integral of 1 over the square root of 4x squared plus 1 with respect to x. So here, we knew that the given radical expression is 4x squared plus 1 is the one that we're going to use to identify the right triangle or the sides of the right triangle, okay? So let me just write that expression. Oops, sorry. Let me just erase it. Okay, here we go. So let me write again. So 4x squared plus 1 is equal to, it can be written as 2x squared plus 1 squared. So as we could see, this is our side 1, and this is our side 2. So we don't have a hypotenuse at this moment, a specific hypotenuse, but we can consider the whole expression as the hypotenuse of a right triangle. So here we need to draw the right triangle, and this is our theta. And we said that our hypotenuse is 2x or 4x squared plus 1. And let's identify where to place 2x and 1 as the sides of the triangle. And again, based on the given table, since we have 4x squared plus 1, then we could use the tangent, right? So tangent, since we're talking about both sides, okay, of the right triangle. So tangent is equal to the opposite. So here we want to make the opposite as the variable. So that's 2x. Okay, and this is the 1. So we have 2x over 1. And this becomes x is equal to tangent theta over 2. So this is now our x. Okay. And since we have dx here in this expression, so we need to find an equivalent expression of the square root of 4x squared plus 1 in terms of the trigonometric function using the given or the constructed right triangle. Okay, so we have, if we're going to consider this, so this is the square root of 4x squared plus 1 over the constant, which is 1. Okay, and what trigonometric function that deals with this? Hypotenuse over adjacent. So that's hypotenuse over adjacent, and this is cha, sha. That's secant, right? Secant theta, sha. Okay, so we have secant theta is equal to hypotenuse over adjacent. So therefore, secant theta is equal to 4x squared plus 1. So which means that we can substitute this expression by secant theta alone. Okay, and also we need to identify the dx here, since we already found what dx is. What x here, which is equivalent to tangent theta over 2. Then we can differentiate both sides to get the dx. Okay, equivalent expression of dx. So this is 1/2. And what's the derivative of tangent theta? The derivative of tangent theta is secant square, right? Secant square theta with respect to theta. Or you can also use the natural logarithm of the absolute value of cosine, of secant, or the negative of the natural logarithm of the absolute value of cosine. But let's go with secant square theta, okay? Let's make it simpler at this moment. So we have already identified the expression square root of 4x squared plus 1 and the dx. So I think we're now ready to substitute these trigonometric expressions in the given problem. Okay, so let's write it here. So that's the integral of dx is equal to 1/2. Okay, 1/2 of the secant square with respect to theta. And again, this expression square root of 4x squared plus 1 is equivalent to secant theta, right? Okay, so let's simplify. Since this is constant, we can just put that here. Okay, the integral of, and we can simplify, we can cancel out secant theta. All right, so what we have is secant theta with respect to theta. So here, we have this expression, and so to find the integral of secant theta with respect to theta, then we need to remember a direct formula that says the integral of the secant theta with respect to theta. And as we knew, the integral of secant theta is equal to the natural logarithm of secant theta plus tangent theta plus c, right? Since we have already discussed this in or under the topic trigonometric integrals, so we can use this formula now. And again, if we're going to check or interpret our final answer in relation to the given problem, we are using trigonometric functions while the given has no trigonometric functions. The given is expressed in terms of x. So we need to find a way to express secant theta and tangent theta in terms of x. But then again, we have already drawn a right triangle, okay, a while ago. So we will be using that again in order to convert secant and tangent theta to in terms of x. So let's just remember or copy the sides here. So this is 4x squared plus 1. This is 1 and this is 2x. Okay, so let's start with secant. So our secant theta is equal to sha. Secant is hypotenuse over adjacent. So that's 4x squared plus 1. And tangent theta is equal to opposite over adjacent. That's equal to 2x. Over 1 is equal to 2x, right? Opposite over adjacent. So therefore, we can now substitute. Our final answer is 1/2 times the absolute value of the secant, which is 4x squared plus 1, and plus the tangent theta, which is equal to 2x, is equal plus the the constant. Okay, so let's see if we got the correct answer. Oh, here we go. So we have the same answer as we are expecting. Okay, this is supposed to be the answer. So the answer in number 4 is 1/2 of the natural logarithm of the absolute value of the square root of 4x squared plus 1 plus 2x plus c. And I hope we got the same answer here. Okay. Now let's move on to another problem, number 5. And the problem here says find the area enclosed by y is equal to the square root of a squared minus x squared using integration. Okay, now at first, let's write the given equation first. Y is equal to the square root of a squared minus x squared. Okay, if we're going to analyze the given equation or function, this is an equation of a square, okay? Manipulated equation of a square, how? So let's simplify this or try to square on both sides. So this becomes y squared is equal to a squared minus x squared. And we can transpose x to the left side. So that's x squared plus y squared is equal to a squared. And the a squared here could be considered as r squared, which is the radius, which means that the radius is equal to a, right? So therefore, we can draw this equation here. Okay, so let's just draw that. And let's say this is our a, and if this is a, this is our negative a, all right? And here, since it's a circle, therefore, it should have a radius of a and, okay, a, and a, and a. So it's a circle. But in the given, we're just going to consider the positive, the principal square root of a squared minus x squared. So therefore, our graph will just pass through the upper portion of the upper portion of the x-axis. So that's here. And we will be removing the portion of the circle below the x-axis, again, because of principal square root, or the positive values of y only. Okay, so let's draw the graph using yellow. Okay, let's try sketching the graph here. All right, so here we go. Here we go. So this is the circle, or the semicircle. Oh no, okay, let me erase that. Let me erase this first. Okay, so this is now our circle, a semicircle with a radius of a. Okay, so this is our radius is equal to a. And since we're talking about the area enclosed by this function, and of course the x-axis or the y is equal to 0, then let's try sketching cyan. Let's see cyan. Okay, we're talking about the area here of this circle. Okay, so the area here. There we go. So this is the area that we're trying to find out. Now, with the use of the integral, okay, or integration, we can find the area of this. And let's consider a vertical rectangular strip. Okay, let's use another color. There we go. And we're going to use this rectangular vertical strip as our basis in finding the area of this shaded region. And we know that this is the x and this is our y, right? Okay, these are the x and this is our y. But then again, for us to identify the area, we need to identify the equation first of the regions bounded by the following equations. Number one is y is equal to the square root of a square minus x square. And of course, this curve or equation y is equal to 0, or the x-axis. Okay, and so we're now ready to identify the expression, the working equation to find the area of this region. And by the way, since we're using a vertical rectangular strip, this is our upper and this is our lower. So our working equation is the integral of y upper minus y lower with respect to x from negative a to positive a. So that's negative a to positive a. Since we're talking about circle or a semicircle here centered at the origin, we knew that these two parts, the left and the right parts, are symmetrical, which means they have the same area, okay? And also, which implies that we can find the area of the shaded region by, okay, by getting the difference of the equation of the upper minus the lower with respect to x from 0 to a. Why 0? We can start from here until here, which is a. Okay, this is 0. And since they're just the same or equal, so we can just multiply this by 2. All right, so this is now our guide on how to find the area of this region. So let's substitute the values of y sub u, the upper, and the y sub l, the lower. Okay, let's go to the next slide. So let me just change the color. So I have, again, that's 2 times the integral of y upper. Our y upper is the ax squared, the square root of a squared minus x squared, minus the lower, which is 0 with respect to x from 0 to a. All right, so let's simplify the expression. This is the integral from 0 to a of the radical or the square root a square minus x square with respect to x. Here we go. Now, if we're going to analyze the given integrand, now this is in a form of, okay, we can use the trigonometric substitution, okay, to solve for this integral, and we can use our guide under the expression a square minus x square. And using the guide, we can use sine here, sine theta here, okay? But let's just verify that. Okay, let's use a right triangle again. And okay, and this is our theta. And in this given, we know that this is our hypotenuse and this is the side, right? So hypotenuse is A, and our side, so let's say this is theta, and we know that x should be here over something. So x over, okay, and we don't know where to find, where to plot the x in this triangle, okay? But so we're choosing which side to plot x. It's either here or here, and the other side is a square minus x square, okay? But since we're talking about opposite, so we could have that here, okay? We can use the sine theta, which is opposite. So opposite over hypotenuse, that's a. Better use a instead of using the other side, which is a square minus x squared, to avoid from getting more complicated expressions, okay? So sine theta is equal to x over a, and we already identified where to put x, a, and the other side, the square root of a square minus x square. So let's solve for x. X is equal to a sine theta, all right? So we already found the value of, x in terms of the trigonometric function sine. And also, however, we need to express, or we need to convert this into trigonometric expression or function as well, correct? So what we need to do is to identify the trigonometric function that deals with this expression. So we know that theta is equal to, okay, let's set that here as our numerator, so as we'll not be having any more problems finding an expression, a complicated expression using this side. And let's deal with a constant for easy or a simpler expression again. And what kind of trigonometric function do we have here? This is adjacent over the hypotenuse. So adjacent over hypotenuse. So right? So cosine. So this is cosine theta. So cosine adjacent over hypotenuse is equal to this. Therefore, a cosine theta is equal to a square minus x square. So we have already found, okay, let me just use another color. So we have already found an expression for this, which is this, okay? And we're still, oh, we don't have dx yet. Since we're going to express this in terms of the trigonometric function, then we need to express dx in terms of a trigonometric function as well. But how do we do that? We will be using here, this equation with the x. And how do we find the d of x, or dx, sorry? We need to differentiate, okay? Take the derivative of this equation. And let's move on to the next. Okay, let's use white. All right, let me just copy. So that's x is equal to a times, let's review, sine theta. So to find the dx, we have the derivative of x is dx, okay, is equal to, sorry. Oh, so let me just change that. Here we go. All right, let me put it to white. So that's equal to dx is equal to a. The derivative of sine is cosine theta with respect to theta. So we have already find dx. So we have the integral of, oh, this is 2. The integral of the square root of a square minus x square dx from 0 to a. Okay, we can now substitute all the trigonometric functions to all of the terms that we have here. So square root of a squared minus x squared is equal to, that's a cosine. So a cosine theta, and our dx is equal to a cosine theta as well, with respect to theta from 0 to a. All right, here we go. So now let's simplify the given integral. So we can factor out a and a, so that's 2a squared. Why? Because a is a constant, right? So we have cosine squared theta with respect to theta from 0 to a. Okay, so our problem right now is to find the integral of cosine squared theta. So we will be using the topic integrals or trigonometric integrals to find the antiderivative of this expression. So we have 2a squared, and we need to convert this to an identity of cosine squared theta, which is 1 plus cosine 2 theta all over 2 d theta. Okay, and how did we convert that to that expression? Oh, sorry. So let me just wait. Okay, and how did we get this? Because we know there's an identity for cosine square. There we go. So cosine square theta is equal to 1 plus cosine 2 theta all over 2. This is what we call power reduction identity or power reduction formula. Okay, we reduce the power into this expression, which is 1 plus cosine theta all over 2. All right, so that's why we have this. And let's simplify. Okay, and let me just change the color again to white. So let me just let's simplify this expression. Okay, so we have 2a squared times 1/2. Let's put the constant to as a coefficient, which is 1 plus cosine 2 theta with respect to theta from 0 to a. Okay, and we can simplify this. So this becomes a squared, okay, 1 plus cosine 2 theta with respect to theta. Okay, now to integrate this, let's integrate this term by term. So let's distribute. So with respect to theta from 0 to a plus a squared, the integral of cosine 2 theta with respect to theta from 0 to a, right? So this is our integral 1 again, and this is our integral 2. So let's solve these integrals. So first, we have, let's solve integral 1. Integral 1 is equal to a squared, all right, a0, so with respect to theta, and this is a squared theta, okay, and this is a0. However, a and 0 are values of x at the very beginning, okay? You might be confused. Uh, you might be tempted substituting a to theta and 0, and that is wrong because a and 0 are values of x. They're not values of theta. So you better put x here for you to be reminded that we need to convert theta first to x for you to substitute the values of, or the upper and lower limits 0 to, sorry, a and 0 respectively. All right. So again, we're not supposed to be substituting a0 to theta because they're not the values of theta yet. Okay, so what do we do that here? Or what do we do with this? Okay. Now, what we need to do is we need to convert, to express theta in terms of x for us to use 0 and a. And how do we do that? Again, what we have is a we know that, sorry, okay, how do we do this? Now let's draw a right triangle again. Let's review this. We have theta, and let's check the triangle. Okay, here we go. So this is our A, this is our X, and this is our A squared minus X. And we knew that, what is our X? X is equal to A sine theta. Okay, sine theta is equal to opposite over hypotenuse X over A. Therefore, theta is equal to the inverse of sine X over A, right? Here we go. So since theta is equal to the inverse of sine of X over A, then we need to substitute this value here, okay, in integral 1. So let's substitute that one here. So let's copy. Integral 1 is equal to A squared theta. X is equal to A and X is equal to 0. And this is A squared. Again, this is the inverse of sine X over A. All right, X equals A and X equals 0. Here we go. So since we have already expressed theta in terms of the trigonometric function of in terms of X, okay, or the inverse of sine of X over A, then we're now ready to substitute the values of X, which are 0 and A, as the upper and lower limits, okay? So we have A squared, and by the way, guys, we're just on integral number 1. So we have the inverse of sine, okay, the upper A over A minus the inverse of sine, the lower 0 over A. Close. Okay, so let's simplify if we can. This is the inverse of sine 1 minus the inverse of sine 0. Here we go. So we need to simplify this. We need to simplify this and this. And let's analyze. So the inverse of sine 1 is equal to theta, all right, which means that sine theta was equal to 1. So what is the value of theta here such that, or the angle measure such that when we take its sine, then you will get 1. In a unit circle, the value of sine that makes it 1 is just this, right? Because this is 0, 1, and this is what measure, that's pi over 2. So therefore, we have theta is equal to pi over 2, correct? Okay, so this is the value of theta here. And also here, it's the inverse of sine theta is equal to 0. And we could say sine 0 is the inverse of sine 0 is equal to theta. So we could say sine theta is equal to 0. Now, using the unit circle, where does sine theta become 0? It's here or here, okay? However, as we knew, okay, the sign should be from 0, from negative pi over 2 to positive pi over 2, so which means that we will be using this, okay? We're not going to take this anymore because it was part of the restriction in the table for the trigonometric substitution guide, all right? The one that we discussed before. So the theta here is equal to 0, okay? So we found this theta and another theta which is equal to 0. So let's substitute these values of theta here, all right? So we have, okay, integral 1 is equal to A squared times, okay, let's go back. The value of theta here is equal to pi over 2 minus, and the value of theta here is equal to 0, or the value of this is equal to 0. So therefore, this is 0. Therefore, I sub 1 is equal to A squared pi over 2 for I sub 1, all right? And let's move on to integral 2. Okay, for integral 2, our expression is a square cosine, what's that? Cosine 2a, 2 theta. Cosine 2 theta with respect to theta from 0 to a. Okay, here we go. So to solve this, we need to let u is equal to 2 theta. And the derivative of u is du, and theta, all right, so, sorry, d theta, this is 2, correct? Okay, by substitution method. So we have equals a square, the integral of cosine u du over 2 from 0 to a. Again, please be careful that a and 0 here are the values of x. So a square, all right, over 2. Since this is constant, we can put it as the coefficient. So the integral of cosine u du from 0 to a. So we have a square over 2. Okay, what's the integral of cosine u? That's sine, right? Sine cosine. Okay, here we go. So that's sine u, and sine u is equal to u is equal to 2 theta, so that's 2 theta. Okay, and to be evaluated from 0 to a, but again, these are the values of x. Make sure that you write x here, or else you will be tempted to substitute a to theta, right? So we have a square over 2. Okay, and let's substitute sine 2. Oh, sorry, I'm now substituting. Okay, so let me erase. See, I told you, so you need to be very careful. Okay, so we need to, for us to substitute a and 0 here, we need to express this in terms of x, because these are the values of x. So let's move on to the next slide. Okay, all right, so we have again integral 2 is equal to, okay, a square over 2. Okay, let me rewrite that. Sine 2 theta, a0 is equal to x, and is equal to x. Okay, and for us to convert this into x, then we need to use an identity. We know that sine 2 theta, sorry, 2 theta is equal to 2 sine theta cosine theta. All right, that's what we know of. Okay, because it's sine theta plus theta is equal to sine theta cosine theta. Sin cos cosine, cosine theta sine theta. And to simplify this, we'll have this. So therefore, we can use this. Okay, we can use this identity to solve for this. All right, so we have okay, so now we have a square over 2, 2 sine theta cosine theta. A equals x and 0 is equal to x. Again, we cannot substitute x's yet because this expression are in terms of theta, not on x. So we need to convert sine theta and cosine theta in terms of x. And to do that, we need to draw the triangle again that we drew a while ago. So this is theta. Okay, let's review the triangle. AX, AX, and this is our a square minus x square. All right, so let's solve. So sine theta is equal to opposite of our hypotenuse, a, okay, and cosine theta is equal to a square minus x square over hypotenuse a. So we have a square over 2. Oh, I can cancel this now. So this a square times sine theta is equal to x over a times the square root of a square minus x square over a, here we go, a0, x and x. Since they are all, these a and 0 are values of x, and we have already expressed this in terms of x, so we have a square, we have x, a square minus x square over a square, right? A0. Okay, and let's now go to the next. So we have integral 2 is equal to a square, oh sorry, x square, x over a square minus x square. And this is a and 0. Here we go. So we have a square. If this is a, so this is a over a square times, this becomes 0, right? Minus, since x is 0, so this is 0. So everything is 0. Therefore, I2 is equal to 0. Therefore, I1 plus I2 is equal to, I1 is equal to what? I1 is equal to, oh, what is I1 equal to? Here we go. It's a square pi over 2 plus 0. So this is a square pi over 2. This is our final answer. And if we're going to analyze, or if we're going back to the figure, a semicircle, right? Since it's a semicircle, the formula of a circle is pi r square. Since it's a semicircle, that's pi r square over 2. And this is our formula, since a is the radius. Therefore, we get the correct formula, which is a square pi over 2, because it's just the same as this, right? Or equal. They're similar because our radius is not equal to a here. This is our general formula, but with a given equation y is equal to the square root of a square minus x square, then our formula for the semicircle is this, a square times pi over 2. Okay, so we found already the answer, right? And I hope you understood the solution. It's quite long. If you have questions, you can comment under the video. Thank you.